It's going to be done except for movies you saw it.
All right, we'll get going. 6:30. We're waiting all morning for this time. I gotta minimize this. Yeah, we're gonna talk about wire rope here in a few minutes. Some corporate announcements. We have a new front desk person, Crystal Devereaux. So say hi to her. She's part-time, right, Ben? So,
Yes.
Yep. And Ivan Lano, is he around? Is he here? Ivan?
Manu.
He's a returning guy. And Kenneth Wells. Kenneth here? Right. Okay. Welcome, everybody. All the new ones. Make sure you introduce yourself. Okay. Technical discussions today. Fluid mechanics and pumps still. There's a lot to talk about on this subject. And today we're going to talk about buoyancy. And buoyancy is an upward force on a submerged body and is a concern for flotation of a pipe, a manhole, a tank. Even when a body is submerged by fill, if it's below water, it can pop out. Sometimes the pipe is weighted down or anchored down, and deep structures below groundwater frequently have a thickened slab that maybe extends beyond the structure, but not beyond the barrel sections, to engage more earth to resist that flotation. And horizontal directional drilling work sometimes considers the loading of the pipe with water to prevent high buoyancy forces of the pipe against the borehole and possibly crushing of the pipe. If you had, say, a large diameter, maybe a 36, 42-inch PE thin wall pipe, doesn't weigh very much, and that's a lot of water that's being displaced, so there's a lot of crushing force on it as well as an upward force. So just to look at the physics of it here a little bit, and we have water up here, and I have a submerged pipe. So a pipe, an empty pipe, just has the weight of the pipe, nothing else, and it's displacing weight of water. So you can actually figure out weight of pipe. Usually just look at a chart, and then weight of water is just a calculation based on that volume that we're displacing times the unit weight of water. So an example here in the buoyancy force, by the way, is the weight of water we're taking out minus the weight of the pipe. So for example, a 24-inch steel pipe, 3/8 wall, weighs 102.6 pounds per linear foot of pipe. And that weight of water over that same 1 foot section is 196 pounds. So obviously there's an upward buoyant force from that difference in weight of 93.4 pounds. So
Per foot.
Per linear foot. So there's a lot of upward force. Yeah, it could be a real lot on a large diameter pipe. So if you have a crossing below a lake, usually they have to anchor it down or have enough weight of the pipe, or sometimes put anchors or saddles or all kinds of things like that. And this is another example of a manhole structure. This is from the National Precast Concrete Association on their website. And like I said, that sometimes you have slabs that are used to tie down or add weight. And you have, the weight of the structure. They have broken down weight of soil on the lid, weight of soil on the sides, and the weight of the structure. And so that's all meant to resist that uplift flotation. If you had water up here, it's completely submerged. And I guess maybe I'm making the point down here a little bit further. Buoyancy is independent of the depth of the water. So it could be 100 feet of water, it could be 10 feet of water. A pipe that's completely submerged will have the same upward buoyancy force. But if you think about a different structure, like a manhole, say with an open top, it does increase. You got a 100-foot deep, manhole that's submerged, then you have all that whole column of water. So it's open at the top. It really would take the full height. This is kind of an example where it's closed at the top. But it's like taking a paper cup and pushing it into the water. It increases with resistance as you go down. So something to keep in mind. Obviously, we're dealing with these sort of things a lot, whether we're installing manholes or whether we're tanks. We've done underground fuel tanks, storage tanks, and all that sort of thing. Sometimes with tie-down anchors or weighted dead man anchors.
A lot of manholes will float with enough water.
That's right. And sometimes a job site might be partly complete, say putting in manholes, and then maybe you get a storm and maybe your excavation is not backfilled all the way. You could have a trench full of water you could possibly get a manhole that pops right out.
We've had it happen.
Yeah, I'm sure. I'm sure it's happened to just about everybody. If it hasn't happened to somebody, it will happen to somebody, right? So something to keep in mind. Water is a very powerful force, as we are all aware of. So for a project this week, I'm highlighting the V-Trans Newberry I-91 Bridge 62-3S pavement repairs. That's at milepost 103 on the southbound lane of 91. That's way up in the, not really way up in the Northeast Kingdom, but I guess that would be considered the Northeast Kingdom. It's just the town south of Reigate. So Newberry, actually, Wells River is part of Newberry. There's West Newberry and Newberry Village or something. There's a lot of different parts. The interstate runs right through. The exit to the north is Wells River, the P&H. Just to the north of here, to the south, we're looking south. To the south is Barnett. So we did a repair because they had a bump over an existing culvert going underneath the roadway here, and it was a substantial bump, and they had us go in and repair that by removing the pavement, excavating down, what was it?
12 inches.
12 inches removal of gravel, replacing that gravel and putting it all back. So, we did that. It was a 224-foot section on both sides. We did it by phasing half at a time. Did the passing lane first, set up all the traffic control, did the coal planing, excavation, backfilling this week on the passing lane. And we are paving with our traffic control and signs and barricades. And then this next week we'll shift that traffic over to the passing lane while we perform the work on the right lane and the shoulder to complete the project. So, pretty interesting job. I think as I get close to the code of conduct item week, got to mention it. Work in an environmentally conscientious manner. One thing that comes to mind is make sure you have spill kits and complete spill kits in your job trailers on your job sites as well. If you don't, Matt can set you up.
I'm in the crib.
Yeah, okay, tool crib. So, okay, Matt's going to talk about wire rope.
Yep. We're going to continue on our rigging inspection. We've done chain and synthetics, and the last is the wire rope. I'll kind of just pass this around. The biggest thing I want to just point out to everybody is where we're seeing a lot of issues with wire rope is when we're using it in a basket form like this, or like this, however we want to rig it, is we're starting, you really need to start seeing the bird caging that you see here in this wire rope, which you'll see is it's starting to separate. It's the D over D ratio, which I'll get into more detail in the next couple of weeks. But what happens is we start overworking and it's too much of an area tension and it starts separating. And actually what you'll see is on the inner side, we'll start flattening out and breaking the inner parts of our wire rope. So I'll go over more of that detail later, but for the most part, it's just going over inspection of wire rope. Again, we want to have tags on all of our wire rope. That one there is missing a tag. Remember, wire rope is rated in tons. Okay, synthetics, chains, everything's in pounds. Wire rope, for some reason, it's different. It's in tons. Remember, every 1 ton is 2,000 pounds. So something that is really, it's an easy calculation to figure out, but just something that everybody hopefully knows by now. But again, just with wire rope, it's broken down into a couple different sections. It's very mechanically formed piece of rigging. You have a core, you have wire, center wires, and then strands. Okay, and then one lay. You need to kind of know this because for inspection, you should know what a lay is. One lay is the distance for a strand to make one revolution around the diameter of your wire rope. So it's one strand is this strand here to make one full revolution. So as that's going around, you put your thumb on it and make it go one revolution of that strand. If you see 10 broken wires in one strand, something like this, we'll need to take this out of service. Kind of with wire rope, when in doubt, take it out. But the regulations kind of say 10 broken wires in one revolution. You'll see crushing. Okay, you see something like this. Usually, if it gets at 90 degrees, we're picking up something 90 degrees. You'll need to take it out of service with crushing, or something drives on a pinch point. Permanent kinking. What you see very frequently with improper rigging techniques. Hopefully next week we'll start getting more into the rigging technique stuff, but you'll see permanent kinking of the wire rope. We'll need to kind of, hopefully if we can unkink it, but when it's permanently kinked, we need to take it out of service. And then the bird cage is what I was kind of talking about with our true basket, or not true basket, but when we're basket hitching our wire rope, you'll see this bird caging, or you'll start seeing the strands separate from each other. And that's going to be a big indicator that we really should take that out of service, because when these things fail, they fail very, really suddenly and violently. So something to look at. We don't really have any more of these in service. That was one of our last bad pigtail slices that we have. But you can't have this. This needs to cover all the way down to the single or live line of your wire rope. But something to look at. We have a lot of wire rope out there. We're using more and more of it lately, especially around the crane and some of the bigger picks that we've been doing lately. So really inspect your stuff. Before you send it back to the shop, inspect it, or before it goes to you, or if it's the first day on that job, really do a good thorough inspection. If you don't have time, call me. I'll come out and do a good thorough inspection on all of our rigging. Something that Larry did at CCTA, it worked out great on that project. We were able to have enough time to order some new stuff where it wasn't a delay in the job, but it's very important that we don't take our rigging for granted. We're putting this away properly in job trailers, hanging up. They shouldn't be in the back of pickup trucks. If we're not using them and you don't really need them for the project, bring them back. We'll put them in our rigging building so they're accessible for other projects to use. Very handy tool, but again, we need to make sure we stay up on the inspections of it. And when in doubt, notify me. I'll come down, do a more thorough check. If we have to take it out of service, we will. Next couple of weeks, we'll really start getting into some of the technical parts of actually rigging all the different types of hitches and some good rigging techniques, so hopefully that we don't damage our rigging. Is there any questions regarding wire rope inspections? 10 broken wires in one leg. When in doubt, take it out of service. Okay.
10 bothers me.
Yeah, it's the regulations, you know.
Yep. Bring it in. We'll replace it. Okay. State check.
Huh? So that we're at make sure. Yeah.
Ben, you want to do these?
Sure.